Prepare to rethink what you know about Jupiter's mysterious core, because the newest scientific findings are shaking up one of astronomy's most debated topics. For decades, the prevailing wisdom was that Jupiter's unusual core resulted from a catastrophic collision with a massive protoplanet. An event so intense it could have scrambled heavy elements deep within the gas giant's center. But here's where it gets controversial. Recent research suggests that this dramatic impact theory may be all wrong. Instead, it looks like Jupiter's core composition is actually the result of a far more subtle and gradual process. Scientists used to believe Jupiter's core had a clear solid boundary, detectable beneath its thick layers of hydrogen and helium. However, data from NASA's Juno spacecraft revealed something unexpected. Jupiter's core seems to fade seamlessly into its surrounding layers, forming what experts call a dilute core. Imagine pouring syrup into water. Over time, there's no obvious line between the two. They blend together. That's Jupiter's core, and understanding how it formed has left researchers puzzled. To get to the bottom of this mystery, an international team of scientists from Durham University, NASA, SETI, and the University of Oslo ran a suite of highly advanced supercomputer simulations. They specifically aimed to test whether planet-smashing impacts could create Jupiter's strange, diffuse core structure. Employing the Dirac Cosmos supercomputer and the latest simulation techniques, they put Jupiter through some truly cosmic collisions. Think planetary smash-ups, more intense than anything we could imagine. And this is the part most people miss. Not one of their simulated impacts managed to replicate Jupiter's smoothly blended core. Each time, the heavier material would resettle quickly, creating a sharp divide instead of that gradual, mixed transition observed by Juno. It seems the dramatic impact scenario can't account for the real-life structure seen in the planet today. Dr. Thomas Sandys, who led the research, summed up the finding with a sense of awe. It's remarkable to witness, even virtually, how a world as massive as Jupiter withstands such violence, only to settle into a configuration that doesn't match what's actually out there. Intriguingly, Jupiter's not unique in having a dilute core. Similar evidence points to Saturn sharing this elusive trait. Dr. Luis Teodoro from the University of Oslo noted, finding diluted cores in both Jupiter and Saturn backs up the idea that these aren't rare phenomena caused by once-in-a-lifetime impacts, but rather are the products of slow, steady accumulation and mixing of different materials as planets form and evolve. This revelation could have far-reaching effects on how we interpret hundreds of gas giant exoplanets orbiting distant stars. If Jupiter and Saturn's cores grew through gradual evolution, perhaps these processes are common, meaning many, if not most, gas giants could harbor fascinatingly complex interiors. Dr. Jacob Kegereis, another co-author, drove home a bold point. Giant impacts do happen in planetary history, but pinning every mystery on them is a dangerous oversimplification. Our work not only rules out one widely held theory, but also pushes the boundaries of how we simulate the wild, chaotic processes that shape entire worlds. Here's a spicy question for you. Do you think these results truly settle the debate about Jupiter's core? Or are there still giant gaps, pun intended, in our understanding? Could another even more exotic process be at play? Or will new data make us rethink everything yet again? Jump into the conversation below and share your perspective. Do these findings make you question the classic theories? Or do you still see merit in the idea of epic planetary collisions shaping our solar system?